All right. So problem number 13, the question is, they have this graph here of an absolute value function, and it says, will the inverse be a function? And so, I don't know what the giggle in is. All right. Well, anyway, stay focused. Stay focused. Will the inverse be a function? So here's what I'm going to do. I want to point out a couple of points on the graph, okay? Thank you. So I'm going to point out this point. This is -3, comma 3. And then this point over here is +3, comma 3. So let's do our function, which is in blue. We'll call this f because that's what the graph is. So my domain, I have -3 and I have +3. And then for my range of f, I have 3. And so I have one arrow leaving the domain and range to the value of 3. That's okay, as long as only one arrow leaves the domain. Where we run into an issue is when I have f inverse and the domain and the range get flip-flopped. So in other words, over here I have 3, and over here I have -3 and +3. And if I map those, anytime I have more than one arrow leaving the domain in a mapping, that's not a function. I'm going to spell the word function.
You are not the function.
Yeah, be quiet. So technically, I can't even use this notation. I can't even call it this. I have to say the inverse, right? So this is just the inverse. And we talked about this. Remember that in order for us to have a inverse function, you have to have what we call a 1-to-1 function in order to get an inverse function. So let's talk about function versus equation. Equation is a mathematical relationship where we have one side of the equal sign equal to the other side. All right? And that doesn't change, mathematically speaking. A function is an equation where I have one unique output for each input, right? So when a function looks like this, where I'm going to plug in one input, whatever that x value is, and I'm only going to get one y. That's why there's only one arrow coming out of here, right? Now, that's a function. But you can have an equation like our inverse, and let me draw that in a red box so you guys can understand what I'm saying. You can have an equation where you have, for example, this is just an equation that's the inverse, and I have this one value of 3, but I have two outputs, -3 and +3. Well, that's not a function, okay? So we have to have what we call a 1-to-1 relationship, one input, one output. Yes?
Why didn't you use 4, 3, since it's like -3, 3, 3, 3? Why did you only use 3?
Oh, I see what you're saying. Because when we talk about domain and range, there's no point to count the same value twice, especially when we're doing a mapping, right? 3 is a unique number. And so the question, let me see if I can word the question differently. Your question was, why didn't you just map them separate, right? Because if I mapped them separate, in other words, like, why didn't I do something like, why didn't I do 3 maps to -3 and then down below that say 3 maps to 3, right? Because when I talk about the domain, 3 is one number on the number line. that maps to two separate numbers. So I have to only list it once. We don't list the numbers more than once. Does that make sense? Okay. All right. Another way that you could tell if the inverse function, you could do, remember that a function is a function when you do a horizontal line test. All right, let me back up. A function is a function when you do a vertical line test. So the inverse flips the x and y. So you could do a vertical line test to see if the inverse function or the inverse would be a function. So if I were to do a horizontal line test like this, it crosses more than once. And because it crosses more than once, that means that the inverse would not be a function. Does that make sense? Okay. Can we move on to the next one?